Ladies and gentlemen, we will start our second lecture in the Define Phase module. The following topics will be covered during the lecture: brainstorming, affinity diagram, specify CTQ requirements, problem statement. We will use the brainstorming technique in the Define Phase to provide a group with a wide range of creative ideas around any topic. It is used to identify customers to include in research. It is used to identify potential causes of a problem to investigate. It is used to identify types of data to collect. It is used to identify solution ideas. How to brainstorm. Review the problem definition and clarify the goal and the question. Give everyone a few minutes of silence to think about the question and individually write down some ideas. Use stick notes, no criticism, and encourage creativity. Gather ideas, do a round to collect ideas, no discussion, and continue till all ideas are collected. Post ideas and consolidate similar ideas. After a brainstorming session, the affinity diagrams is used to organize a lot of ideas, opinions, and issues into groups, and also, when information about a problem is not well organized. How to do affinity diagrams. Gather ideas from brainstorming session. Write ideas on cards, or self-stick notes. Please state only one idea per card. Post self-stick notes randomly, on a board, or flip chart. Allow to silently start grouping, or clustering the cards or notes. When the clustering is done, create a header label for each group. The header will be written on a note, or card. A theme may be suggested for a group of headers. If you're working with customer needs, themes may represent customer needs, and you can move into developing requirements based on those needs. An example for affinity diagram. Why not use Lean Six Sigma? These are the suggested ideas coming out from brainstorming, answering the last question. Now, we will group the cards under the following categories: culture, planning, organizing, management, and IT issues. Under culture, we have resist change, need for creativity, behavior, and lack of trust. And under planning, problem first or team, do not customer needs, no definition for the problem. While, under organizing, lack of follow-up, too busy, lack of training. And under management, we have competition, pressure to success, what are the reward? Lack of management support. And finally, under IT issues, data collection, unused collected data, unrealistic time allocated, too many projects at once. The following exercise is adapted from Schmidt et al. Consider the problem as clearly stated. What are the barriers to a quality improvement program? The suggested ideas to answer the problem are listed here. Please arrange the previous ideas in 4 groups, as listed: management, communication, training, resources. Please pause the lecture and solve the exercise. Please compare your solution with the exercise solution. The purpose of critical to quality trees is to convert customer needs and wants to measurable requirements for the business to implement. For example, a retailer was receiving a significant number of complaints regarding their after-sale service to their customers. By analyzing customer survey data and developing the CTQ tree, as in the next slide, the business was able to identify critical to satisfaction requirements. For the needs, in our example, good customer service. There are 3 drivers for this needs: knowledgeable representatives, fast response, and short wait. For knowledgeable representatives driver, the CTQs are: answers given by representatives are correct. Representatives can answer questions by customer on the spot. For fast response driver, the CTQs are: customer greeted by name, customer not interrupted. For short wait driver, the CTQs are: customer is placed on hold, customer transferred quickly to a person who can help them. Factory has a quality issue of deviation in the weight of 1 kilogram milk powder pouch. Could you please help them by analyze the CTQ tree for them? By analyzing the data, they found 6 drivers can lead to this problem: people, method, machine, measurements, environment, and material. For each driver, suggest the CTQ related to it and design the CTQ tree. Please pause the lecture and solve the exercise. Please check the exercise solution and compare it with yours. Review existing data or other sources of information in order to confirm that the following conditions met in the problem statement and goals. Clear description for the problem with measurable facts still exists. Specify when and where the problem is happening. Only one problem involves in the problem statement. Is important to customers, to be sure, collect the voice of the customer. Is important to the business, to be sure, collect voice of the business information. Can reasonably be expected to be improved using Lean Six Sigma, DMAIC, methodologies. Please note the following when writing the problem statement and goals. This part of the project documentation has been postponed till other parts of the defined phase are completed. Do not assume root cause or solutions in the problem statement or goal statement. Root causes are identified in analyze phase. Solutions are done in improve phase. Problem statement example: the WSH paint booth does not provide sufficient capacity to paint 100% of the element cases required to support current volume during last month and continue. Project goals example: this project will increase the capacity of the WSH paint booth by January 2021 by a sufficient amount to reduce the need for outside processing of element cases by more than $50,000. The stretch goal is to eliminate outside processing. The secondary goal is reduction in unit cost with more than 10%. The goal includes deadline for improvement target. The goal includes quantity or extent improvement target. No solutions assumed for the problem. Problem statement example: current process has paper feeding 3 machines to produce the product. Lack of systems and off-quality product are causing excess waste, greater than 10,647 tons annually. The paper machine adds more than 10,000 additional meter to each reel in order to make up for future losses. Project goals example: reduce waste by 5% annually starting next year. Increase utilization from 85% to 90%. Increase awareness on the operating floor. The goal includes deadline for improvement target. The goal includes quantity or extent improvement target. no solutions assumed for the problem. In our exercise, the next project goal statement is wrong, please correct it. Reduce the width between the spinning and winding stages by increasing the operators in both stages. Please pause the lecture and solve the exercise. Please check the exercise solution and compare it to your solution. Please note that the goals are wrong because no quantity or extent improvement target. No deadline for improvement target. Assume solutions for the problem. The correct project goal: reduce the width between the spinning and winding stages with at least 25% before starting of next year. To design a correct project scope, specify what is in scope and what is out of it. The project scope defines the boundaries of the project. The project scope keeps the team on purpose, in alignment, contained, focused, and motivated. The scope include 1. The start time and stop time. 2. The duration. 3. The process boundaries, what is within the scope and what is out of the scope. 4. The sub-processes involved. 5. The product lines, the locations, the divisions, the states, the territories, the countries, etc. Here is a Sigma Excel template for Project Charter. It includes all the important outputs of define phase, problem statement, goal statement, project scope, project plan, and team. Here is a template for project plan. For every action, you should state the start date, the description, the priority, party responsible, the due date, the date of completion, and status. Please check the activities of the defined phase in the course material or in the resources. Please perform the required activities and send your outputs by email for assessment. Now, we will perform checklist for the defined phase. In case of unmarked point from your point of view, please replay the 2 lectures of defined phase, check the course materials, watch the instructional videos, check the templates, and perform the activities. We will perform the checklist for the following. For team. All Lean Six Sigma roles in the team are assigned. All other team members are nominated and trained in Lean Six Sigma. The team members know their roles within the project and have all necessary resources. For problem. The problem statement are clearly written. For Project Charter. Business case, problem, and goal are formulated in smart way. Focus and scope, net benefit, milestones, and project schedule are defined and agreed on. For SIPAC, the key outputs and the customers of the process are identified. For customers, the voices of the customer, VOCs, are collected and classified. The voices of the customer, VOCs, are translated into specific and measurable requirements. For quality, the critical to quality components are determined and specified. It is time to start your project. Please make a brainstorming to specify and write down the following: project title, location of the project, problem statement, project charter. Please follow the following guidelines for project selection. Any project should have identifiable process inputs and outputs. A good Six Sigma project should never have a predetermined solution. If you already know the answer, then just go fix it. For projects that have operator or operator training as an input, focus on ways to reduce operator variation by making your process more robust to different or untrained operators. All projects need to be approached from the perspective of understanding the variation in process inputs, controlling them, and eliminating the defects. Thank you, and see you in the first lecture of measure phase.